Listen up, y'all, cause this is it. The numbers we're making are so vicious. Mathematicious expeditions
It's me,
can be kind of scary.
Mr. Wharton.
I hope my answers
And this is your 6.2 multiplying and dividing radical section. And we're going to start going over some rules for multiplying radicals. I'm just kidding. What if I talk like that? That'd be crazy. 6.1 was all about simplifying how to break them down and make them smaller and kind of go through that process. 6.2 is going to talk about how to multiply and divide radicals with different powers, square roots, cube roots, stuff like that, but also how to actually kind of multiply the things together. So some rules. We got to go over these first. These are really important. So I'm not going to necessarily put numbers next to them because it's not like a specific order that you're going to do things, but there's some things that you're just going to watch out for. So the first thing is you have to make sure that the indexes are the same. Make sure the indexes are the same here. If the indexes aren't the same, then you can't multiply them together. This is going to be a hint here that all of these indexes are going to be the same. We just have to make sure that they are, but they all should be anyway. So the second thing that I want to discuss here is when you multiply radicals, we want to multiply insides with insides and outsides with outsides. We don't want to mix the two. We don't want to do an inside with an outside and an outside with an inside. We don't want to do that. We want to multiply insides with insides, outsides with outsides. That's pretty much what it is. Another thing, I guess this will be the first thing if you ever want to talk about like specific rules. The very, very first thing, so I guess it should be this is a 1 and then this would be a 2 here, is really to break down roots first. Break down roots first. What I mean by that is if you have the square root of 8, you know that this can be broken down as what, 2, 2, and 2, which is really 2 square root of 2. Break it down first, and then it's going to be a lot easier to multiply later, because otherwise you're going to be getting really large numbers on some of these, and it's kind of not going to make sense, or it might make sense, but it'll be really large, and it'll be kind of hard to kind of fix them and finish them out. So that's really the three that you got to know. And we're going to do a whole bunch of practice with this anyway, so it's really not going to be anything out of the ordinary. It's going to basically, the more times you do them, the better off you're going to be. So let's get to the couple examples there. So again, multiplying, I want to multiply inside with inside, outside with outside, but I want to break it down first. Well, 5 and 2 cannot be broken down. So inside with inside, so that's root 10. 5 times 2 is 10. Outside with outside, so negative 4 times 1 is negative 4. That's it. That's all we're doing. This is not that terrible of a section. Number 2, this is, again, I want inside with inside, but I want to break it down first. Well, 10 is 2 times 5, right? Times 5 root 5 over here. So there you go. That's what I have. What did we say square roots and cube roots and fifth roots and all that stuff is? It's basically saying that I need the root or the index, right? This is a 2 and a 2. This tells me how many I need of each specific term or individual number or variable. So I only have 1 5 here, but I'm actually combining it with this 5 over here. So because I have 2 5s on the inside of my radical, I can pull one of the 5s out, cross the other one out, and then now that 5 that you brought out gets combined with the other 5 that's already there. So that makes a 25. Root, what number did I not touch? That 2, so that is your answer there. That's the hardest part to understand. You could very easily have done inside with inside, and you get 5 root 50, and then you got to break 50 down as 5 times 5 times 2. 5 pops, that crosses out, and the 2 stays in. You can do it that way too, but when we get to big numbers like down here with 32 and 64 and 20 and 15, even these are kind of large, and I don't want to do that. So if you do it the first way that I showed you right here, this will make more sense. Number 3. I have 4 root, break it down, 3x to the third times a negative 4 root, what, 2x squared. I'm sorry, 223x squared. Negative 4 root 223x squared, right? So that's all underneath that. And then I want to do, again, insides and outsides and all that stuff. I want to do them together here. So this is a 3. So one of the 3's can pop. The other 3 gets crossed because that's a pair. I have a pair of 2's there, so the 2 gets crossed. I have 3 x's here and 2 x's here. Well, how many do I have total? I have really 5 of them. But my index is a 2. How many 2's can go into 5? We've talked about that in the last section. And then I pull that quantity out, and then I keep the quantity that's left on the inside. So let's finish this problem up. So 3 I brought out, which is 12. So 12, okay. This 2 I brought out, which that's an 8, okay, times a negative there. And then x to the 5, well, what did I say? How many 2's go into 5? Well, that's 2, okay. And how many's left on the inside? Well, I'm left with 1x on the inside. And if I look, there's 1 3 here that I didn't touch. So that 3 is left on the inside. And now I multiply the outside numbers together. Negative 96x squared root 3x. There you go. Inside, inside, outside with outside. It's not any more complicated than that. Number 4, let's go here. This is root 20, which is actually 2, 2, and 5. And then r to the third times a negative 4 root 3, 5, and an r. So I have a 2 pops, the other 2 gets crossed. This 5 pops. Well, why? Because I have another one over here that gets crossed out. And then how many r's do I have total? I have 4. So because it's a square root, I can pull 2 of them out, right? 2 of them out. So I get a 2 and a 5 that popped. Then the negative 4 is still there, so it's multiplied by that. I have 2 r's that popped. And then what stays in? Well, what's the only number I didn't actually touch? Well, that 3. And I don't have any r's that I didn't touch, so let's multiply those together. That gives me a negative 40 r squared root 3. Please don't get confused and say, oh, this is 10 minus 4. No, it's not. It's 10 times a negative 4. Okay, 10 times. Number 5. Well, now I'm dealing with higher roots, right? This is a 3, this is a 4, that's a 3, and that's a 4. Oh, man. These are going to get kind of crazy, but if we, again, break it down first, it will help. What is 32 broken down? 32 broken down is 2, 2, 2, 2, 2. There are 5 2's in 32. And then what's 4 broken down? 4 is broken down as 2 and 2. Again, I have the third roots there, that 3. So this 3 tells me I need 3 of each number. So I have 3 2's right there. I have 2 more there and 1 more here, right? So one of the 2's gets popped, those cross out. Another 2 gets popped out, that one crosses, and this one over here crosses. So how many pop out? The 2 of them became a 4. And then I'm left with a third root of how many 2's that I didn't touch. Oh, that one right there, and that's it right there. That's what I'm saying. Break the number down, because otherwise you're going to be dealing with 128, and you're going to have to do it from there, and that's just kind of stupid. You might as well just break it down first. Number 6, this is negative 4th root of 4, which is 2 times 2, times the negative 4th root of 4, which is 2 times 2. I have how many 2's? 2 and 2 make 4 of them, so I can pull one of them out, cross, cross, cross. So the 2 gets popped out. I have a negative times a negative. Well, that's just a positive. And then nothing left inside, so that is my answer, my lone 2. It is a lone wolf. Number 7 here. In the last section, I talked about if I have an odd root with a negative, that this negative just pops out. Okay, so it goes away in there, but it pops out. So it's really a negative 3 times the third root. 48 broken down is 2, 2, 2, 2, 3, a to the 3, times the 4, the third root there. And then 8 is 2, 2, 2, a to the 4. You got a lot of 2's. Okay, well, how many do I need? I need 3 of them. So I have 3 of them here. So 1 pops, cross, cross. Do I have 3 more 2's at all? Oh, yeah, I do. I got 3 right here. So there's 3. 1 pops, cross, cross. So now let's multiply the numbers that come out. So 2 came out with that, so it's a negative 6. What's left there? That is 3a to the third times the 2 popped out here, so that's an 8. And then I have a third root of a to the 4. Now all my numbers are good, but my variables aren't. Sorry, I need a 3 there. So all my variables are not. So how many variables do I actually have total? I have 7. So how many groups of 3 can I make? Well, I can make 2, so I have to pull 2 of them out. So it's negative 6a squared. I got to pull 2 of them out. What is left? Well, I still got that 1a is left, right? 7 minus 6 is 1. And then I still got the 8 there as well. So this is being multiplied by 8. So my answer is negative 48a squared third root of a. Sorry, I keep forgetting the 3. Don't forget the 3, please. That'll be marked wrong. Okay. Number 8 here, 32. We already said 32 from over here was 5 2s, so 1, 2, 3, 4, 5, and then with the p, times the fourth root of 64. Well, if 32 was 5 of them, that means 64 is going to be 6 of them, because it's multiplied by another 2. So 1, 2, 3, 4, 5, 6, p squared. How many total 2s do I have? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Dang, that's a lot of 2s. So I'm going to pull a 2 out, cross 2 more, or 3 more out, I'm sorry, and a group of 4. I'm going to take another 2 out, and then cross 3 more out. And then I don't have 4 left, I only have 3, so I am done pulling numbers out. How many p's do I have? I only have 3. I can't pull any p's out, so here's my answer. 2 2s came out, made a 4. I have the fourth root left. I have 3 2s, which makes an 8. 8, 2 times 2 times 2. And then 3 p's, which makes p to the third power. That is your answer for number 8. Okay, what I want you guys to do is try these 4, starting at number 9 through 12. 2 of them are just square roots, and then 11 and 12 are a fifth root and a fourth root. I want you to try them real quick, hit pause, and then hit play. Okay, if I look at number 9, I want to break them down first. So 20 we know is 2, 2 and a 5, and then an R, and then 18 is a 2, a 3, and a 3, and then an R. So again, I need groups of 2. So I have 2 2s, so I pull a 2 out, cross it out. I have 2 3s, so I pull the 3 out, cross the other one out. So I pulled out a 2 and I pulled out a 3, so that makes a 6 times the negative 6 that's already there, so it's a negative 36. Can I pull out any R's? Yeah, I can pull out one of them because it's R squared. And then what do I have left? What did I not touch? I didn't touch a 5 and a 2, which makes a 10. That should be your answer. There should be no R's left inside. Number 10 here, I have 60, which is 2 times 3 times 5 v squared times a negative 2. And then 12 is 2, 2, 3 v to the third. V to the third. 2s, I have 1, cross it out. I can bring out 1, cross the next 2 out. I have 2 3s. Oh man. So bring a 3 out, cross the other 3 out. So what's left outside? 2 times 3, it's a 6, times a 2, which is 12, times a negative 2, which is a negative 24. Can I bring any of these out? Oh yeah, heck yeah I can. I have 5 inside. I need 2. How many groups of 2 can I pull? I can pull 2 of them out, times the square root of what did I not touch? I didn't touch a 3. 3. And then I should have just the v left inside. That was pretty easy, pretty self-explanatory there. Number 11, I have 5 on the outside times the fifth root. 27 is 3, 3, 3, and k to the third, times the fifth root of 567. So that is, 567, you're going to have to probably do your factor trees and do that way, but you should get 3, 3, 3, 3, 7. I think that I'm right. I believe I am. So then what happens? Oh, then I have a k to the third there. I'm sorry. So I need 5 3s. I have 3 of them here and 2 more there. So one of the 3s gets pulled out, right? And then the other 4 3s gets crossed out. So I pulled out a 3, which makes a 15. I don't have a number here other than just a 1, right? So it's still just 15. Can I pull any k's out? Well, yeah, I got 6. I need 5, so I can pull 1 of them out. And then I have the fifth root of what is left. 2. I have 2 3s, that makes a 9. And then I should have 1k left. That is your final answer there. Number 12. Oh man, we're getting some bigger numbers. This is going to be lovely. Number 12, 162. So the fourth root of 162 is, 2 times 81. So that's 3, 3, 3, 3. And then times a negative 5. And then the fourth root of 729. So that's 3 times 3 times 3 times 3 times 3 times 3. Man, that's a lot of 3s. Those should be a v and a v to the third power. So How many 2s can I pull? None, because there's only one of them. How many 3s? I need groups of 4. So there's the group of 4. 1 pulls, the other 3 gets crossed out. There's a group of 3 here, or a group of 4, I'm sorry. That pulls, cross, cross, cross. Any V's pull? Yeah, I got 4 V's, so that means one of them gets pulled out, and the other 3 get thrown away. So I pulled a 3 out here and a 3 out there, so that gives me a 12 here. That gives me a 15 here, and I pulled a V out, so that's fine there. And then times the 4th root of what? 4th root of what? A 2, and then 2 3s, which makes an 18. 18. Don't have any variables left. This is just being multiplied by that. Sorry, I know that kind of looks weird. But then I get negative 180 V to the 4, or V times the 4th root of 18. So that is your final answer right there. Hopefully you guys did okay in the multiplying section. Multiplying section is a little easier than the division section because the division section is going to be crazy. It's going to get a little cray-cray up in here. And by here, I mean the classroom. All right, with the division of radicals, this is going to be the most complex part of this specific section because then in 6.3, you're going to kind of do some other radical division, and that's going to get a little more complicated. So we need to make sure we know how to do the division of radicals here, the easy stuff, and then when we get to the complicated stuff, hopefully it'll be a little bit more easier, or a little bit easier, or a little less confusing. Okay, so we don't necessarily, again, have rules here like we did up in the top, just same kind of thing. We're just some important concepts that we need. There are some things that I want to talk about what we want to do first. So the first thing that I want to try to do is to try to simplify first. And I'll explain what that is. Again, I'll go through the problem on how to do it. The second thing is I don't like, so let's put it, let me try to rephrase this here a little bit. There shouldn't be roots in your denominator, like in your final answer. If your final answer contains a root in your denominator, then you're wrong. Okay, then you are wrong. That is without a doubt. I'm not going to look at the rest of it. So there shouldn't be any roots in your denominator. Well, why shouldn't there? It's just not proper. It's not mathematically proper. It just doesn't look good. That again puts you in like math jail. Okay, think about that from last unit as well, or last section as well. I talked about that. The third one here, I want to, how do I make sure that there is no square roots or cube roots or whatever in your denominator? You are going to multiply the top and bottom, so the numerator and denominator, by what you need. And you're like, what do I need? What do I need? I need an A. That doesn't mean I'm going to give you an A. But what I need is nice numbers that will get rid of my root. Okay, so hopefully the examples will help. If they don't help, then again, you need to ask questions in class. But with the examples, they should help. Okay, so let's go through 13, 14, and 15 here. Okay, with 13. So if I want to simplify first, what does that mean? That was, remember, that was the first thing in our rules. We talked about simplify first. If I look at these roots here, root 5 and root 3, they're both monomials, right? Numerator and denominator, both monomials. So what I can do is I can simplify inside the roots if I could. If 5 and 3 were divisible by something, then I can make those smaller. But in this case, they're not divisible by the same thing, so I can't make them any smaller. So what I can do now is, then I can use now the third step, or the third rule, or whatever I wrote down at the top, that said I need to multiply the top and bottom by what I need. Okay, and here's where I'm talking about what I need. Well, if we think about this, this is really an index of 2. So this means I need 2 of something. Okay, well, that something is the 3. That's what I want to do. So I want to multiply the denominator and the numerator by the square root of how many more 3's do I need in order to cancel out. I just need one of them. Okay, this is what we call rationalizing. We're going to talk more about this next section, but I'm going to mention it now. Rationalizing is basically what we're doing is we're going to rationalize the denominator, and so that we end up with no square roots on or in the denominator there. Okay, it's called rationalizing. So square root of 3 times the square root of 3, remember a 3 pops and the other 3 gets crossed off. So now my denominator is now a solid 3. There is no more roots down there, so that's good. That is good. On the top, let's multiply 4 square root of 5 times square root of 3. Well, how do I multiply square roots? I multiply inside with inside, outside with outside. So outside 4 times outside 1 is 4. Inside root 5 times inside root 3 is inside root 15. Because I didn't reduce anything here, most of the time it's not going to reduce here. Sometimes it will, sometimes it won't. You just kind of have to check. But there you go, right there. 15 is not reducible, so that's it. Number 14. Now, again, you have the same roots, 3 and 3, the same indexes, right? And you need the same. That's a given. That's like we did on multiplication. You need the same down here as well. I want to get rid of the root 2. The 5 is not in a root, so I don't care about this right now. So how do I have to multiply the top and bottom by to get rid of the 2? Well, this tells me how many I need, and I only have one of them. So I'm going to multiply by the third root of how many more 2's do I need to get rid of them? Well, I need 2 more 2's. So I'm going to multiply the top as well by 2 times 2. Now, one of the 2's can pop out. The other 2 2's, haha, 2 2's, can get crossed out. Again, like we've done before. You have 3 of something with a cubed root. 1 comes out. The other 2 gets crossed out. Now, let's multiply the top. 2 times 2 is 4, times 3 is 12. So the third root of 12 over, well, I pulled out a 2 with the 5, so that makes a 10. I don't have anything that's able to reduce. Just like you said, inside with inside when you multiply or outside with outside, same thing when you divide. Okay, this is outside of a square root, and this is inside of a root. I cannot mix them together. Okay, I cannot mix insides with outsides and vice versa. Number 15. The first step up there said simplify if I could first. Well, what does that mean? That means that if I can pull stuff out and make it smaller, then let's do that. Remember, this is u to the third, that's a 2, so I can pull a 1u out. And then I have the square root of 5uv, okay, and then 3 on top. Sorry. And then now let's multiply here. I need the square root, there we go, of what? I have 1 5, so I need 1 more. I have 1u, I need 1 more, and I have 1v, need 1 more. So the square root of 5uv for the top and the bottom. Now let's multiply insides with insides, outside with outside. So 3 outside times 1 outside is 3 on the outside, times the square root of 5uv. Remember, I don't need to write that 2 for the square root. It's understood, but if you want to write it, be my guest. That's just more writing for you, but hey, you're all right. Now let's multiply the bottoms. Because I have 2 of everything here, a 5 gets pulled, a u gets pulled, and a v gets pulled. So I'm left with a 5. I pulled out a u, but I had a u already there, so it's u squared. And then I got a v that comes out as well. That's it for number 15. For number 16 here, again, I want to break down your inside there and the root in your denominator. So it's technically you have the 4 that's there, you have the third root, and then break it down. So 16 is 2, 2, 2, and 2, and then an m and an n all under, right, that's all on the bottom, other than negative 3m squared n. Now this negative, technically it does go to the top, so that's why I just put it to the top. You don't have to do that. It's just something that just makes sense. I just want to make sure it's still there, okay? Don't forget about it. So let's reduce first. I can pull the 2 out. I can cross 2 of the other ones away. So this technically is an 8, okay, times the third root of what? Of 1 more 2 and then an m and an n. Sorry, an n. There we go. Now let's multiply top and bottom by what I need. So I have the third root of how many more do I need? I have 1, 2. I need 2 more of them to make 3. I have 1 m. I need 2 more of them. And I have 1 n, and I need 2 more of them. So that's what's going to happen by the top and the bottom. So 2 times 2. M squared, n squared. So I just kind of cleaned it up a little bit. So I'm going to take out a 2, I'm going to take out an M, I'm going to take out an N, then everything else gets crossed out. Oh yeah, it does. What is done in your denominator? What is there? Well, the 8 times the 2 they brought out was a 16. I brought out 1 M and 1 N. On top, I need to multiply insides with insides, outside with outsides. So this is all outside, and that's a 1 there. So it's a negative 3M squared N. And then this is all on the inside, so that just stays there, times the third root of 4. 2 times 2 is 4. M squared N squared. And that is your final answer right there. Okay, well, apparently this is not right. I apparently circled it by accident, but it's not, so I'm looking at it again. If I look here, I have M squareds and N's, and I have M's and N's on the bottom. So just like we talked about in Unit 5, where I have a fraction with some variables, I actually have to simplify these. Okay, so this is technically just 2 M's on top, 1 on the bottom, so that one's gone, and this becomes just a 1, right, just the number 1. And then I have an N on top and an N on the bottom, so now those are now canceled as well. So that makes your final answer negative 3M, and then the third root of 4M squared, N squared, over 16. And that is it. That is your final answer. Okay, that is the right one. Hopefully this time it's the right one. But I'm going to clear some of this so that we can get to number 17 and then number 18 there as well. 17 looks a little different because I have a binomial in the numerator, but that's not that big of a deal. Okay, and then 18 as well. With 17, again, I want to break down your denominator, but 17 I cannot be broken down, so that's your prime number, right? So I want to multiply top and bottom by something, and I need a square root, so I have a square root there. I need 2 of them. 2 of what? 2 of 17s. So I need to multiply top and bottom by root 17 over root 17. The reason why I multiply the top and bottom by the same thing is because, remember, technically this makes a 1. And if I multiply anything by 1, I don't change the value of the fraction or anything before it. So it looks different, but I don't change the value. So now on the top, or let's do on the bottom first. I have 2 17s, so 1 comes out, the other one gets crossed out. So my denominator is 5 times 17, which is 85. Now my numerator, I have what? I have a binomial and a monomial. So I'm going to distribute this square root of 17 with the 1 and the 3. So I'm going to multiply this times this, and this times this. But again, what did I say? Insides with insides, outside with outsides. So this is a negative 1 root 17. And then this is going to be plus root 51. 3 times 17 is 51. I cannot reduce any of them, so I am done. That wasn't that bad. Number 18. Again, I want to simplify first if I can. 14. What is 14? Well, 14 is a 2, a 7, an N, and an N. Right? That just breaks it down that way. It's very simply there. Then I want to multiply top and bottom by something to get rid of it. Well, I have 1 2, and I need 4 2s. So I got to multiply by 3 more 2s. Then up for the 7, I have 1 7. I need 4 of them. I got to multiply by 3 more 7s. And then I have 2 n's. I need 4, so I got to multiply by 2 more n's. So that was, it looks pretty complicated, but once you break it down this way, it makes more sense to do it this way here. So I need a 2, a 2, a 2, a 7, a 7, a 7, and an n and an n. So now let's figure out what I get on the denominator part. 2 gets pulled, 7 gets pulled, n gets pulled, then everything else just basically cancels, right? So everything else goes away, boom, 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 there we go. That makes a 14n. That is your denominator, 14n, 2 times 7 times n. Up top, this gets distributed to the 4 and distributed to that there. Okay, so negative 4 is going to stay there, times the 4th root of what? Of, that's 6, oh, I'm sorry, 2 times 2 times 2 is 8. Holy cow, this is a big number. 2 times 2 times 2 is 8, times 7. I'm going to pull up my calculator here in a little bit. Well, maybe I won't, but just use your calculator to calculate it. But 2 times 2 times 2 is 8. 7 times 7 times 7 is, oh man, 7 times 7 times 7 is 343. Okay, and 343 times 8, so I got to multiply that. So 8 times 343 is 2744. I had to use my calculator for that one. I didn't pull it up, but it's okay. You just use your calculator. I use my Wabbit one on my phone. Now, that's all crazy. So that's going to be the number inside, right? 2744. And then I have an n squared as well there. Plus what? Well, this is again getting distributed with the fourth root of 2n to the third power. But now if you look, I have a 2 on the inside plus 3 more. If I have fourth root, that means one of the 2's gets pulled out, right? And then the other ones get crossed out. And then I have 5 total n's. So that means one of the n's also gets pulled out. Okay, times, how many 7's do I have? 3 times, that's 343 from before. And I should have 1 n left inside. So I know the 14n is not there, but if you want to, put it in the middle, that's fine too if you want to, do that. But that is your answer for that one. Okay, apparently I made another little error here. This is not your final answer in 18 as well. I'm just like circling wrong answers, I guess. The reason why this is not right is because if I look at the numerator, when the binomial, technically I have this, right, plus all that stuff over 14n, but this is a 4, and that's a 2, and that's a 14. So all of those numbers can be divided by 2. So this technically becomes a 2 there. That goes away, and this one becomes a 7. So let's rewrite that here over here. I just kind of shifted to the right a little bit. So I get -2. I get the fourth root of 2744 n squared plus, now I took away that 2 there, so that's just an n. And then I get the fourth root of 343n. 343n, okay? It's my numerator. And then my denominator, I took away the 14, made it a 7, so that's a 7n. Now this has an n here, and this has an n, but since that 2 in front of the parentheses, or in front of the root there, I'm sorry, doesn't have an n, I can't get rid of that. Okay, so this is your final answer. I hope to not have this happen again in this video, but I guess, we'll see. But that's it, and then moving on to the next section there. Okay, number 19 through 22 are very similar to what you just did, so I want you to practice right now. Go ahead and try, hit pause, and then hit play. Okay, hopefully you paused for a long enough amount of time, and I want you to at least try these, okay? If you finished them, great. If you didn't, again, we need to make sure we're going wrong here. So here we go. This one here, 3 and x squared. Technically, because it's an x squared and that's a square root, I can pull an x out. So this is really written as 2x to the third over x square root of 3. Then I need to multiply the top and bottom by just a root 3 and a root 3, because I need one more of the 3's, right? So one of these pops, the other gets crossed off. So my numerator is 2x to the third root 3 over, then 3 pulls out with the x, so 3x there. Then I can simplify, okay? This gets crossed off. This 3 becomes a 2, right? X squared's left on top because I can basically take one x away. So answer, I get 2x squared root 3, over 3x. 2x squared root 3 over 3x. Number 20, let's break it down first. All right, number 20. There's a couple different ways we can do number 20. I'm going to do it kind of, I'll do it both ways. Actually, I'll kind of show you here the differences between them. So the first way is, because these are the same indexes, 3 and 3, I can simplify the numbers inside first. So this really simplifies to 3 times the third root of 1 over 3 times, or I'm sorry, the third root of, then I divide, right? 4 divided by 4 is 1. So 12 divided by 4 is 3. And then the k and the k to the third, or fourth, became k to the third, right? I simplified. That goes away, all of that. This became a 3, and this became a 3 as well when I divided. So let's finish it up now. Third root of 1, well, any root of 1 is always 1, so 1 times 3 is just 3. This is now the third root of 3k to the third. Well, this is k to the third, so one of those k's pop, right? So I get k times the third root of 3. which needs to be multiplied by the third root of 2 more 3's, top and the bottom, because I have 1, but I need 3. So then here's my answer. 3 times the third root of 9 over, and then one of the 3's pulls out, right? And then the other ones get crossed off, which over 3k, which then the 3's can cancel, and I'm left with the third root of 9 over the variable k. Man, that was a lot of work, okay? I bet you the next way that I'm going to show you is probably going to be more work than that one, okay? So that was the first way. Here's the second way you can do this, and I'm going to kind of erase what's already there. Okay, here's the second way here. I want to, again, break this 12 down, so that's a 2, a 2, a 2, and a 3. And then k to the fourth, remember one of the k's gets pulled out, so I am left with 3 on top, third root of 4k, over 1k gets pulled, right? So k outside, third root of 2, 2, 3, and a k, because I pulled 1k out, but 1 is still left inside. Times, now let's multiply to get rid of my 2's and my 3's and my k's on the inside. So how many 2's do I need? Well, I need 1 more 2. How many 3's do I need? I need 2 more. How many k's do I need? I need 2 more k's as well. That means the same goes for the top. So 2, 3, 3, k equals the 2 gets pulled, a 3 gets pulled, and a k gets pulled in the bottom. Everything else disappears. So a 2 and a 3 became a 6. A k times the k that was already there becomes a k squared. Up top, well, this 4 is actually 2 times 2. So that means that now I have 2 2's here plus another 2 there, so I can pull a 2 out, cross the other 2 2's out. So that 2 gets pulled with the 3 that's already there, makes a 6. Then what's left? All right, I can pull a k out because I have 1k here and 2k's here. So 1k gets pulled, the other 2k's get crossed off. And then what is left on the inside? Well, that's a 9. Let's simplify. 6 over 6, gone. K over k squared. That k gets gone. This becomes just a 1. So what do I have left? Third root of 9 over k. Maybe that is shorter. I don't know. I guess to each their own. You can do whichever way you want to do. Number 21. 10 is already broken down. All right, 10 is already broken down, so I don't need to break it down any further. So I'm going to multiply by the square root of 10, square root of 10. Or 2 times 5, 2 times 5, it doesn't matter. That's fine. So I distribute the tops, and I get square root of 30 plus 5 square root of 20 over, remember, a 10 and a 10, so a 10 gets pulled and this other 10 crosses, so that's a 40. Some of you might be like, all right, I'm good, I'm done, right? I'm done, yeah, I'm done, yeah, I'm done. Well, I'm not. This 20 is actually 2 times 2 times 5, so a 2 gets pulled and another 2 gets crossed off, so this technically becomes root 30 plus 10 root 5 over 40. Now, some of you are like, well, I can divide those. Well, yeah, I can if there was a number in front of that 30 that had divisible by 2 or 5 or 10 or 4 or something like that. Okay, so I can't do that because that's just a 1. So that is my final answer. Like Sean Connery. Sean Connery. I'll take that category, Alex. That's a terrible Sean Connery impression. I'm sorry, I just ruined like 4 seconds of your life with that one. Number 22. I need to break down my denominator, which is just what? A 2, an x, and an x. So when I multiply, I need to multiply by 2 more 2's and 2 more x's. So same with the top, 2, 2x, x. 2 gets popped, cross the other 2's out. An x pops, cross the other x's out. So a 2 popped, that made a 6 in your denominator. An x popped, that made an x down there also. Distribute, distribute, distribute. Okay, I can't do anything there, so that's 5 times 4. 2 times 2 is 4, times the 5 is 20. Okay, so that is inside your root there, the fourth root, and then the 5 is out there. And then x to the third and an x squared. Okay, well, that means I have 5 x's. That means one of them can get pulled out and one's left inside. So pull an x out, leave an x inside. Minus How many x's do I have here? 2, and I have 2 more there. That means 1 can get pulled. And then I have no more left inside, times the 4th root of what? 4th root of 4. So, final answer. 5x times the 4th root of 20x minus x times the 4th root of 4 all over 6x. I'm not done. I remember I said that was the final answer. Well, I lied. Okay, I'm not done. Technically, all of these have an x on the outside of my roots. This has an x here, has an x here, has an x here. So that means I can cross them out. I can cross them out. So here's my final answer. I won't lie this time. I'm right. This is my final answer. 5 4th root of 20x minus the 4th root of 4 over 6. And that is your final answer. There. All righty. That concludes your 6.2 multiplying and dividing radicals. All right. If you have any questions, please ask in class. But since you follow this video, make sure you understand all the try it problems, the ones that say you try it. Make sure we're doing those, and as best as we can. Again, ask questions if we need help. But that concludes this video. So catch you on the flip side. Remember, take notes, do work, and you will be successful.